everyone, in this video we're going to look at the normal distribution, also known as the bell-shaped distribution. I think in year 11 you refer to it more as a bell-shaped distribution, but I call it the normal distribution, and so does your textbook and your exam. So let's call it the normal distribution. So basically, if we have a look at this graph here, looks just like, it is a histogram and it's symmetrical. So the normal distribution is symmetrical. All right, it's completely symmetrical. It's not going to be skewed. It is very hard in real life to have data that is completely symmetrical, but a good example is your ATAR scores or your study scores as well. So I just did a quick Google search and found this website which I thought was pretty cool. So it talks about scaling in the VCE. Not that I'm going to go into too much detail about scaling, but it's, you understand what a study score is. So using it to explain the normal distribution, I think will help you with your understanding of the normal distribution. All right, so I love this diagram because I just want to quickly explain how you get your study score. So you complete your SACs and your final exam. So completing your SACs, you're going to be ranked out of everyone at your school doing the same subject. So you guys doing general maths, you'll be ranked, and then you go on to do your final exam, which will have more of an impact on your study score than your actual SAC results. So you get your VCE raw score. So you, at the end of the year, will see that raw score, and then you'll see a scaled score. So some subjects get scaled up, some get scaled down, and some don't change at all. So we're going to look at an example of ones that are going to be scaled up. And then you get your ATAR from that. All right, so we're focusing more on the normal distribution as opposed to scaling. So let's have a look at this diagram here. All right, it's a normal distribution bell-shaped curve, and we're looking at English scores. So our median is 30. So in a bell-shaped distribution or normal distribution, your mean and median are the same, right in the middle. So the median score, the mean score is 30, right in the middle. Now, we know if we're above that, all right, you're going to be above the average. If you're below, you're going to be below the average. But as you get closer and closer to 50, there's going to be fewer students. So that's why it's all to do with the ranking. So the majority of students, if we have a look at this light blue part, would fall into this. And if you did general maths last year, you would know that's approximately 68%. It's not exactly 68%, but it's approximately 68% are in this middle part here. Now, if you got 36 in English, which is a great score, all right, so let's say this is you, and we go across, all right, 20% of students got that score. All right, so as it says here, you outperformed 80% of VCE students. Now, as you go further and further down, imagine if we got maybe 45, which is here, you're probably in the top maybe 4%. All right, so it's really hard to get above 40, and it's great to get above 30. Even if you get above 25, that is a great result, because often if you want to go on to university, it's a prerequisite to get 25. And if you can hear that bell in the background, that's just my dog licking her dog bowl. Sorry about that. She's not ringing a bell, it's her dog collar. Anyway, let's get back to this. So this person who got 36 and this person here, I don't know what that result is, probably around, I would say 24 probably, and that means that 80% of people got a better result than them, but they were better than 20% of people, which is good. So it's basically the inverse of that. So that's your raw score. So this is an interesting article if you wanted to go and read it, blah, blah, blah. Why do we scale? Okay, because basically some subjects are harder than others. So if we have a look at English versus specialist maths, and it is different for each year. So I don't know which year this one was done in, but each year it's different. It's not majorly different, but it does depend on the cohort for that year. So English, if you got a 30, went down 2 points to 28. So didn't change too dramatically, but if you did specialist maths and you got a 30, it went up to 43 because it's a lot harder subject. So looking at it in terms of a bell-shaped curve, all right, so here, if that's your raw score, and then we're just looking at the score of 35 and 40, basically that bell-shaped curve moves along. So it doesn't matter what subject this is. So let's say you got a 30, it goes up to 35, 35 to 40, 40 to 45. Now that is not exactly how it works, and I think it does have it there as a little disclaimer. So it's not adding 5 for each. It does depend on what you get, but I think just showing you that bell-shaped curve and the median as 30, that yeah, you can shift things along, and they tend to get shifted by the same amount. And I think there is this diagram here, which is slightly skewed. All right, so you can see a 30 becomes 35, but a 35 becomes 41, and a 40 becomes 46. And basically, the closer you get to 50, you don't really go up that much. So yeah, so that's a normal distribution. There's other things that are normally distributed, but if you're using real life data like the birth weight of babies, it is a normal distribution, but it is not absolutely perfect, but it's pretty much there. All right, let's get stuck into having a look at a bit of our theory. So here we're just looking at the height. So I don't know what that is the height of, because there's some really tall people down here. But you can see it's just a histogram, and it's got to be symmetrical. You can't do it when it's not symmetrical. So lots of diagrams, and you really need to know your percentages for the normal distribution. If you can understand your percentages, you'll be fine with the normal distribution. For the standard normal distribution, I'll do that in a separate video, but I just wanted to really emphasize the importance of the percentages with the normal distribution. So if we're splitting, let me just start drawing on here. All right, so if our mean, median and mode, so the reason it's equal is because it's symmetrical. All right, so if we're looking at symmetrical data, the mean is equal to the median, which is equal to the mode. So if I'm cutting it in half, obviously would have 50% on either side. I just see, yep, there's nothing really there that we haven't already covered. All right, so we do talk about it in terms of the 68, 95, 99.7% rule. Now, if you do methods, we do normal distribution as well, and you will notice that it is not exactly 68%, it is not exactly 95%, and it's not exactly 99.7%, but it's pretty approximate, all right? So that's why we would see something like approximately or around, those sorts of words. But for any normal distribution, these percentages apply, all right? Because it's the same shaped curve. Even if you had a different mean and a different standard deviation, it would be the same. So when we're talking about mean and standard deviation, let me just cover that. How can I do that? I think we've got a bit of space here. All right, in terms of the mean and the standard deviation, so here's our bell-shaped curve. Your mean is always in the middle. And then the standard deviation is just how far away you are from the mean. So I think I used this example in a previous video. If we were doing the heights of year 12 students, so not the height, sorry, let's say the ages. It might be a bit easier for me to approximate. So we've got students who are probably maybe a few 16-year-olds, maybe some 19-year-olds. All right. If we were taking year 7 to year 12, we're looking at students who are maybe 11 to 19. So you would have a smaller standard deviation, all right, than year 7 to year 12. And if you had a school that was maybe ELC, so kinder, early learning centre, to year 12, you might have kids who are 3 all the way up to 19. So it's even more spread out. All right, so the standard deviation just tells us how far away we are from the mean. So with the normal distribution, we always go 3 standard deviations either side. And that's because 3 standard deviation pretty much covers the whole thing. So if we go back here, 3 standard deviations is 99.7% of the data. It's never going to be 100%, right? It's going to be 99.7%. Even if we had 4 standard deviations, you'll get close to 100%, but you'll never get to 100%. All right, so going to the right side, we're just adding on 1 standard deviation each time. So we've got the mean plus 1 standard deviation, the mean plus 2 standard deviations, and the mean plus 3 standard deviations. Going in the other direction, we're just now subtracting our standard deviations. So S is just your standard deviation. I should do SX. I'll go back and do that. So SX. Because on your calculator it is SX. All right, so your mean is the middle. We know separating it gives it 50%. But if we're going just 1 standard deviation either side, that's where the 68% comes from. All right, 68% is 1 standard deviation either side. So I'm just going to scroll down here. That is what this part is saying. All right, so 68%, 1 standard deviation either side. And that means we've got then 68% in the middle and then 16% either side. So all up, it adds up to 100%. 2 standard deviations. So here we are, 2 standard deviations below, 2 standard deviations above, and that's approximately 95% going from there to there. And just scrolling down, that is what this is telling us. 2 standard deviations either side of the mean, so 95% in the middle leaves us with 2.5 at either end. And then finally, if we're doing 3 standard deviations, so going, let me just write it, 99.7%, all right, we're going all the way to 3 standard deviations. So those percentages are what is being used. All right, so there it is for 3 standard deviations. Now you could get a question that asks you to apply any of those percentages. So what we have in this diagram, which I really like, and I think you should definitely have these diagrams in your bound book, is just what each section is worth. So sometimes you get questions where you've got to look at the percentage between here and maybe here. And you're like, oh, what is that? Well, that just means we're adding this column, and this column together. All right, so we're going to answer a question in a sec that requires you to actually do that. So having this diagram in your bound book is extremely helpful. And I often say to students, having an extra one, because if you get it in a SAC, not that you should draw in your SAC, a bound book in your SAC, but if you get it in an exam, you can draw on the normal distribution that's in your book as opposed to having to rewrite it. All right, so then we're looking at Z-scores. So we're going to look at some questions now. All right, so these were taken from 1H. Now, when I read a question and I see the word normal distribution, I straight away think of drawing the bell-shaped curve. So let's read the question first. So the blood pressure readings for executives are approximately normally distributed with mean systolic blood pressure of 134 and a standard deviation of 20. All right, so normal distribution, I would straight away draw the curve. All right, it doesn't have to, we're not an art class, doesn't have to be perfect, but you do want it to be not tiny. You don't want to do this because we've got to write numbers down here. So if it's too small, you're not going to be able to write your numbers. So use your page, all right? Make sure you've given yourself enough space. Now, it told us that the mean is 134. So I straight away, before even answering any of these questions, I'm going to complete my normal distribution. So I've got 134 in the middle. That's my mean. And then I go 1, 2, 3, either side. All right, 1, 2, 3. And then I start going my standard deviations above, standard deviations below. So standard deviation is 20. So I'm going to add 20 on the right side. So we're going to go 154, 174, 194, and then on the other side I'm going down. So 114, 94, and 74. We're only going to be using those values. So if you do methods, you will work with other values, but here we're just going to be working with those standard deviations. So remember, this is the mean plus 1 standard deviation, the mean plus, whoops, let's go to write S again, 2 standard deviations, the mean plus 3 standard deviations, and then the other side, we've got the mean minus 1 standard deviation, the mean minus 2 standard deviations, and then the mean minus 3 standard deviations. You don't have to write what I've just written underneath, okay, because you should, if you do enough questions, you should just know that. It's a lot of time writing that. Okay, so this first question, about 68% of the executives have blood pressures between. All right, so we've got to look at that 68%. This is where you need to have your notes ready. So we're going up, having a look at our diagram that I've just drawn all over. So let's make it not so overwhelming. All right, here we go. Here's our 68%. So 68% is 1 standard deviation below to 1 standard deviation above. So for this one here, there's 1 standard deviation below, 1 standard deviation above. So my answer is going to be 114 to 154. All right, 95%, going back to our notes, is this one here. 2 standard deviations either side. So on my diagram, I'm now going, let's choose a different color. We're going from here to here. 2 standard deviations either side. So it's going to be from 94 to 174. And then 99.7 is 3 standard deviations. So let's just do this in a different color. All right, so we're going from there to there. So 74 to 194. All right, then we get into some harder percentages. So we've got 16%, we've got 2.5, 0.15, and 50, but you do have to take note whether you're going above or below. All right, so because it's symmetrical, you're either going to be here, which would be above, or you're going to be here, which is below. And it might change depending on the question, but looking at this one, it's not going to be any different. All right, so 16%, again, looking at our diagram, so we want 16% above. So just get rid of all this scribble. All right, so 16% is above 1 standard deviation. So we're looking at, let me just get rid of these as well. 1 standard deviation above. So this is 16%. Remember, if this is 64%, not 64, sorry, 68%. Oh, my dog's going to bark. She's heard something. And then that means that's 16%. Sorry, guys. All right, not too bad. Maybe it's just the neighbor. All right, 16%, 68, 16%. So that we've got 16% is below 114 and 16% is above 154. All right, so you just need to know your percentages. This question is asking above, so it's above 154. All right, 2.5% relates to 2 standard deviations. So that's in your notes. So if you need to have a look, I'm not going to keep scrolling back because you'll get motion sickness. All right, so 95% is between 2 standard deviations. So that means we're left with, on this side, 2.5% and 2.5%. So together it adds up to 100%. So this one we want 2.5% is below 94. And 2.5% is above 174. It doesn't ask that, but if you had to do that, that's what it is. All right, then the next one. Oh, I knew I was going to get rid of that bell-shaped curve. It's all right, we can quickly just draw it again. Terrible, terrible redrawing of the bell-shaped curve. Let's just try it again. Okay, that's maybe a little slight improvement. All right, so for question F, we're doing 0.15. So that's now 3 standard deviations. So again, I know I said I wasn't going to do this, but here's your diagram. All right, you've got all the percentages you need on that page. So that refers to 3 standard deviations. So we're from there to there. So in the middle, we have 99.7%. So that leaves us with 0.15 either side. So we want it below, so it's going to be below 74. And then the last one, which sometimes students kind of forget, but 50% just means you're splitting it in half. So we're splitting it in half. So that means 50% is above 134, but 50% is also below 134. So there we go, 134. All right. Question 4. The distribution of heights of 19-year-old women is approximately normal with a mean of 170 and a standard deviation of 5. So 3 things I'm looking at. It's normal distribution, so I straight away draw my curve. I have a mean of 170 and a standard deviation of 5. So I'm not going to answer the question just yet. I'm going to draw my bell-shaped curve. So we put our mean right in the middle, and then we go 3 either side. Boop, 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 boop. All right, and then we go up and down by our standard deviation. So we're going to go up first, up by 5, and then we're going to go down by 5. So it's just drawing a scale. That is, I looked at the 7. All right, 160 to 155. All right, so now the question is asking what percentage is between 155 and 185. So 155 is here, 185 is here. So I can see it's 3 standard deviations, but if I were you, I would just count. So we're going 1, 2, 3 above. So we're at the mean plus 3 standard deviations. And then we're going 1, 2, 3 below. So that's the mean minus 3 standard deviations. So using your percentages, and you probably already know this one, 3 standard deviations below, we've got, can't even see that, 99.7%. If I was using this diagram, I'm going from here to here. I could add all these up, and I could get 99.7% that way as well. I mean, it's a lot longer. Hopefully you would recognize that it's just 99.7. All right, let's have a look at question 2. So greater than 180. So let's get rid of my drawing. Greater than 180. So 180 is here. We want that percentage just going above. Actually, it's going to keep going, doesn't stop. So that percentage all the way, let me just get rid of that. I feel like this might be a little bit confusing. So we're kind of looking for this whole section here. So we are 2 standard deviations above. All right, so this is the mean plus 2 standard deviations, and it's got to be greater than that. So again, going, where am I going? To our notes. All right, so here's 2 standard deviations above. So I could just add up these 2 numbers. Alternatively, if you knew your bell-shaped curve well enough, you could see that it's just 2.5%. So you could get it either way. All right, so 2.5%. And then between 160 and 175. All right, so 160 is here. 175 is here. So these types of ones are a little bit harder because we're going one standard deviation above and then 1, 2 below. Let's just get rid of that one there. The mean minus 2 standard deviations. So we're not working with any symmetry for this one, but with, oops, let's go back to the notes. We have gone from 1 above to 2 below. So I just need to add up these values here. All right, so we've got our 68 in the middle, and then we're just going to add that 13.5. Whoops, don't want that. All right, so that's 81.5%. All right, question B, in a sample of 5,000 of these women, so we're looking at 5,000, approximately how many have a height greater than 175? So let's find 175, there it is. All right, so we want greater than that. So we're looking at 1 standard deviation above the mean. So that is 16%. So we're just going to do 16% of 5,000. Now, when we're doing a percentage of a number, we just convert it into a decimal. So 16 of 100. The word of kind of means multiply, and then we're multiplying it by 5,000. So we can just plug that into our calculator. And so 800. All right, so 800 women. So question B is a typical exam type question. Question A is a little bit on the easier side. So you might have both types of questions. All right, let's have a look at question 13 and then we'll do 15. I know it's been a long video, but you really need to get these percentages right. All right, the weights of bananas from a certain grower are approximately normally distributed. So remember, whenever we see the phrase normal distribution, we think of our bell-shaped curve. There it is. The standard deviation of the weight of these bananas is 5 grams. 16% of the bananas weigh less than 96. What is the mean? So this time we're kind of having to work backwards. It's not telling us what the mean is. So the mean is in the middle, but we got to use the knowledge that 5 grams is your standard deviation. And we know that 16% weigh less than 96 grams. So if I go back to my notes, let's have a look where we can see 16%. So let's just get rid of some of this scribble so we don't get distracted. Oops. All right, so here is a 16 and here is a 16. So let's think about this number of standard deviations. We are 1 standard deviation either side of the mean for that one. So with my bell-shaped curve, there's 1 standard deviation either side. It has said that 16% weigh less than 96, so the 96 has to go there. All right, so this percentage is 16%. So we've got to work out what the mean is. We know that the standard deviation is 5. So that means I've just got to go plus 5 to get the mean. So that would be, the mean is equal to 96 plus 5, which is 101. Right? So mean weight is 101 grams. All right, looking at the next one, I think this is the last question we're going to do. So the marks scored in an examination are known to be approximately normally distributed. So remember, whenever we see that, we draw our bell-shaped curve. If 99.7% of students score between 43 and 89, estimate the mean and the standard deviation of this distribution. Give your answer to 1 decimal place. Oh, this is a tricky question. It's probably good that we're doing it together. So 99.7, think about how many standard deviations we are from the mean. Here it is. All right, so we're 3 standard deviations from the mean. So I'll put my mean in the middle. Remember, we don't know what that is, but we've got 1, 2, 3, 1, 2, 3. So we know that between here and here is 99.7%. All right, and that is between 43 and 89. So let's think about this in terms of a number line. So if you can ignore that bell-shaped curve, as beautiful as it is, what have we gone up by going from 43 to 89? All right, we can just do that on the calculator. 89 minus 43. So we've gone up 46, all right? That's the difference between our those two values, between 43 and 89. So between that, we're going across 1, 2, 3, 4, 5, 6. So your standard deviation is going to be 46 divided by 6. Do that on the calc. So 46 divided by 6 is approximately 7.7. Wish when they did questions like this, they were actually whole numbers, but anyway. All right, so that means we're going up by 7.7 each time. So if I start at 43, so 43, and we're going to add 7.7. So that's going to be our next point. So that's going to be 50.7 here. Then we're going to add 7.7 again to get 58.4. And then we're going to hit the mean. So we've answered the question if I add another 7, so 66.1. And you could keep going, and you should get to 89 or approximately 89. We did have to round. So our mean is equal to 66.1. You could also do that. Actually, I think it's going to be close. It's actually going to be 66 because we did round. I'll show you another way to do the mean. So remember, it's halfway. So I could just do that 46, divide that by 2, which gives me 23. So I could just then do 43 plus the 23 gives me the 66. All right, so your mean is in fact 66. If we use the standard deviation, we would get 66.1. Just remember, because we rounded it. So if I go here, remember we rounded up to 7.7. All right, that's it for normal distribution. So just remembering your percentages. When you practice past exam questions, you're going to get a range of questions on normal distribution, but the more you practice your percentages, the better. All right, guys, bye.